Dear students, in this lecture we will derive Wien's law from Planck's law of radiation. Now we will derive Wien's displacement law from Planck's radiation law. As in the previous case, I have taken Planck's distribution law in terms of wavelength, which is given by u lambda is equal to 8 pi hc divided by lambda to the power of 5 into e power hc by lambda kt minus 1. Energy density is maximum at lambda is equal to lambda m. That is, whenever we get the intensity maximum at certain wavelength, that wavelength is mentioned here as lambda m, then the differentiation of energy density u lambda at lambda m becomes equal to 0. That is du lambda divided by d lambda at lambda m equal to 0. In order to do that, we have to differentiate u lambda with respect to lambda and equate it to 0. Then look at this, 8 by hc is constant here. We have two functions. 1 by lambda to the power 5 is one function and another function is 1 divided by e power hc by lambda kt minus 1. This is the second function. We can use product rule in order to differentiate this u lambda. I will choose 1 divided by e power hc by lambda kt minus 1 as e power hc by lambda kt minus 1 whole power minus 1. Now applying product rule, we will get, I have taken 8 by hc as common factor since it is a constant. I have taken it out of the differentiable term. Now I will use product rule to differentiate this. It means keep first function as it is, differentiate the second term, plus keep second term as it is and differentiate the first term. Now I will do that. I will keep first function as e power hc by lambda kt minus 1 whole power minus 1 as it is. Now differentiate 1 by lambda to the power of 5. It will give you minus 5 lambda to the power of minus 6, or it can be written as minus 5 divided by lambda to the power 6, plus I will keep 1 divided by lambda to the power of 5 as it is and I will differentiate this term. That will become minus 1 e power hc by lambda kt minus 1 whole power minus 2. Then it is multiplied by the, again differentiating this term, e power hc by lambda kt. It will give you e power hc by lambda kt into, again differentiate this term in the power of exponential term. We will have hc by kt as constant. I have written hc by kt as it is. I will differentiate 1 by lambda. It will give us minus 1 by lambda square. Close the bracket, equate it to 0. This is the complete differentiation of u lambda with respect to lambda. Now taking 1 by lambda to the power of 6 as common factor on LHS and letting x is equal to hc by lambda kt, we have 8 by hc divided by lambda to the power of 6. In the first term, lambda to the power of 6 is in the denominator, but in the second term, lambda to the power of 5 into lambda to the power of 2 is there. It will become lambda to the power 7, but I have taken only lambda power 6 as common factor. Another lambda is left here, that will become hc by lambda kt. I have put hc by lambda kt as x, that will come here. That means 8 by hc by lambda power 6 into minus 5. In the place of hc by lambda kt, I have written x e power x minus 1 whole power minus 1 plus minus 1 into minus 1 becomes plus. I have written plus here, e power x minus 1 whole power minus 2 into e power hc by lambda kt is written as x e power x, hc by lambda kt is x, it is equal to 0. Now by sending 8 by hc by lambda power 6 to right hand side, it will become 0, as lambda power 6 is cross multiplied with 0, it becomes 0. 8 pi hc is multiplied to right hand side, it will come to denominator. 0 by 8 pi hc becomes 0. Then I have rewritten e power x minus 1 whole power minus 1 to the denominator. It will be minus 5 divided by e power x minus 1 plus, here also I have written e power x minus 1 whole power minus 2 in the denominator. It will become e power x into x divided by e power x minus 1 whole square, and it is equal to 0. If we take LCM of this LHS, we will get LCM as e power x minus 1 whole square. If we multiply these left hand side by e power x minus 1 whole square to the each term, we will have minus 5 into e power x minus 1 plus x into e power x is equal to 0. If we multiply this, we will have minus 5 e power x, minus into minus plus 5 plus x into e power x is equal to 0. And if I multiply it by minus 1, I will get 5 e power x minus 5 minus x e power x equal to 0. Now taking common factor as e power x on LHS, I will have e power x into 5 minus x into minus 5 equal to 0, or it can be written as e power x into 5 minus x is equal to 5, or e power x is equal to 5 by 5 minus x. Now applying the logarithm, we will get x is equal to logarithm of 5 minus logarithm of 5 minus x. I have used logarithmic identity log m by n is equal to log m minus log n. This is a non-algebraic equation and it is having a solution x is equal to 4.965. We are not going to calculate it here. We will directly substitute the value for x as 4.965, but we have substituted x for hc by lambda kt. Here lambda is written as lambda m for the maximum wavelength. We will have hc by lambda m kt is equal to 4.965. If we rearrange for this, lambda m into t is equal to hc divided by k into 4.965. Substituting the values of fundamental constants, h as 6.626 into 10 power minus 34, c as 3 into 10 power 8, k as 1.38 into 10 power minus 23, we will have the relation lambda m into t is equal to 2.989 into 10 power minus 3 meter Kelvin. This is the required Wien's displacement law. It says that maximum wavelength corresponding to maximum intensity is inversely proportional to temperature of the black body.